So what we've been working up to with this inverse trig is getting to solving trig equations. So first off, this is a much more basic example, but we're going to solve this equation on the interval 0 to 2 pi. And what that means is we're going to list every answer in that interval of 0 to 2 pi, which is one full rotation of the circle. Then this second part, which is going to take a little different getting used to, is we're going to come up with a general solution to the equation, meaning a solution that I could plug any number in and it would give me more and more solutions. So looking at this first problem, it says sine of theta equals 1/2. Okay, to solve for sine here, we would say that theta is going to equal inverse sine of 1/2. Now before, when we just start with the inverse function, there's only one answer. When you're solving an equation, there are multiple answers. So if you think about the graph of sine, it's going to keep going on forever. There are so many times that sine is going to equal 1/2. So we use our unit circle. We want to know all answers within one rotation from 0 to 2 pi. And notice 0 is included, 2 pi is not included in that interval. So now for sine equal to 1/2, we know that sine is 1/2 at a reference angle of pi over 6. And here's where we need to use this all students take calculus. Sine is also a positive 1/2 in the second quadrant at that pi over 6 reference angle. So for just listing our solutions, we have that first solution of pi over 6, and then the second solution is in the second quadrant at 5 pi over 6. So that's the first part of this answer. Those are all the solutions on the interval 0 to 2 pi. Now for the second part, when it says give a general solution for the equation, what that means is, change colors, anytime I go around this circle, so we went to pi over 6, if I did a full rotation and came back again, that's another answer. If I do a full rotation and come back again, that's another answer. Or if you look at the graph, here's your first answer. If you do a full sine curve, come back up, you get another solution to the equation. Do it again, that's another solution to the equation. Well, every time it repeats is the period. So in this case, think back to our graphs. To find the period, you always did 2 pi divided by b. Well, in this case, there's nothing in front of the theta or the x. So our period is 2 pi over 1, which is just 2 pi. So to come up with this general solution, you take these two answers that you have, and our solution would be theta equals, we're going to have two parts to it. We could have pi over 6 plus any multiple of 2 pi. We're just going to write that as 2 pi n. Or we could have 5 pi over 6 plus any multiple of 2 pi. And that would be your general solution for this equation. So in general, the form for that is you find your answers, your first two answers on 0 to 2 pi. Those are your two primary answers. And then you take each of those and you write it as a plus whatever the period is times n. So if we have a different period, then that value would change. And that's what you can plug in to find any infinite solutions that there are to this equation. So our next one, tangent of theta equals 1. And here's where, because we're going to have to do this general solution, we should just get used to off the bat the period of this graph. Now remember, for tangent, we always did pi divided by b. There's nothing in front of the theta, so it's pi divided by 1, which is just pi. So this way we know when we get to those general solutions, it's going to be something plus pi n. So now to solve this one, this means theta is inverse tangent of 1. So that means y divided by x equals 1. That happens when it's root 2 over 2. So we know our theta, our reference angle, is equal to pi over 4. Now if we look at our unit circle, we have all students take calculus. We are dealing with a positive 1 here. So tangent is positive in the first quadrant, so we need that pi over 4 angle. And the third quadrant, so we need that other pi over 4 angle. So our first answer to this equation is just pi over 4. Our second answer is when we go all the way to the third quadrant, which would be 5 pi over 4. So those are our answers on the interval 0 to 2 pi. Now for our general solution, and tangent's a little bit different here. So gen solution, we still use that base angle, pi over 4. And then the period is pi, so we do plus pi n. Now for all the other functions, we have to list both of the original. However, for tangent, you really only need to list this one, because notice, if you do pi over 4 plus pi, well, that's going to get you to 5 pi over 4, which is the next solution. So we don't need to list that one. It's already implied in this pi over 4 plus pi n. So for tangent, you're only going to need the one line for a general solution. So now we're going to get to the point where we have to isolate the trig function first. So if you're solving the equations, you can't take the inverse until you get the trig function by itself. So you solve it just like you would any normal linear equation. So like in this case, get rid of addition and subtraction first. So subtract that 1 to the other side. And we get 4 cosecant equals 8. Divide by 4. And we get to cosecant of theta is equal to 2. So now we can take our inverse. And theta is equal to inverse cosecant of 2. I always like to think of these using sine and cosine. So this means that it equals inverse sine, and you just flip the inside of 1/2. So we're dealing with positive sine function is positive in the first and second quadrants. And then our reference angle for inverse sine of 1/2 is pi over 6. So we have the pi over 6 angle in the first quadrant, pi over 6 angle in the second quadrant, which means our two answers to this problem from 0 to 2 pi would be pi over 6 and 5 pi over 6. And now for our general solution, the period of this function, we need 2 pi over b, 2 pi again. There's still nothing there, so it's just 2 pi over 1. So our general solution is pi over 6 plus 2 pi n, and 5 pi over 6 plus 2 pi n. And that's it. Now, because the unit circle has a lot of radicals in it, there's going to be a lot of radicals in these problems at times. They still work the same. So we still want to get rid of our addition and subtraction first. So we subtract root 3, subtract root 3, and we get negative 2 cosine of theta equals root 3. Remember, when you subtract radicals, just subtract the coefficients. Divide by negative 2, and we get cosine of theta equals negative root 3 over 2. So now we need to take our inverse and think about our quadrants. So cosine this time is negative. So if we think about our all students take calculus, that means we're looking in the second and third quadrant, and our reference angle for cosine equal to root 3 over 2 is pi over 6. So we need the pi over 6 angle in the second quadrant, pi over 6 angle in the third quadrant. So our two answers between 0 and 2 pi would be 5 pi over 6 and 7 pi over 6. Now for the general solution, and same as it's been all along so far, our b value is 1, so our period is just 2 pi. So our general solution will be 5 pi over 6 plus 2 pi n, or 7 pi over 6 plus 2 pi n. Okay, this last one we're going to do one where there's something going on the inside of the trig function. So for this problem, you cannot divide out the 2 yet. You have to do that after you take an inverse. So first off, that's where I was saying we should always look and see what the period of the function is. So in this case, we actually have a b value, and then tangent normally has a period of pi. So it's going to be pi over b. In this case, b is 2. So our period is going to be pi over 2. And that just means in the general solution, we're going to write plus pi over 2n instead of what we've been doing. So now from here, to solve, there is nothing on the outside of this function. So we take the inverse at this point, and we have, so 2 theta is going to equal whatever inverse tangent of negative root 3 is. So now for tangent, we're thinking y divided by x equals root 3. So that happens when root 3 over 2 is on top. And that is at the pi over 3 angle. So we're looking at a reference angle of pi over 3. So now we want to think about our unit circle here. With a negative tangent, so that means we're going to have an angle, all students in the second quadrant, take calculus. In the fourth quadrant, our reference angle is pi over 3. So from here we know 2 theta, in the second quadrant we have equals 2 pi over 3, or we have 2 theta equals 5 pi over 3. So when there's something on the inside, after you take the inverse, you have to split it up into your 2 separate equations. So now we can finish solving, divide by 2, and we get theta equals a single pi over 3. Divide by 2, we get theta equals 5 pi over 6. So now the problem with these, when you divide by 2, now we're going to have even more answers on that 0 to 2 pi interval. So first we can go ahead and list these out. We know we have pi over 3 and 5 pi over 6. And now here's where that period's going to come help us out. To get the rest of our answers, we know our period's pi over 2. Take pi over 3, add pi over 2 to that. Take 5 pi over 6, add pi over 2, and that's going to give you more answers in the 0 to 2 pi period. So to do that addition, we have to get a common denominator. So pi over 3 is 2 pi over 6. Pi over 2 is 3 pi over 6. Add those together and we get 5 pi over 6. Okay, so we already have that answer. That will only happen when we're dealing with tangent. Now we have to add pi over 2 again. So 5 pi over 6 plus pi over 2 is 3 pi over 6. That gives us 8 pi over 6, which reduces to 4 pi over 3. So there's another answer. Add pi over 2 again. So 8 pi over 6 plus another 3 pi over 6. 8 plus 3 is 11. Now we get up to 11 pi over 6. Now we know we're at our limit because 2 pi is 12 pi over 6. We can't add another pi over 2. So our 4 answers in the range from 0 to 2 pi are pi over 3, 5 pi over 6, 4 pi over 3, 11 pi over 6. Again, this extra listing happens when you have that extra number inside the trig function. Now, lastly, general solution. And we start with that first value, pi over 3 plus pi over 2 n. Now, normally we have to list 2 for the general solution, but as you could see, just listing that 1, when we added pi over 2, that got us to the next answer already. So this is just saying we can add pi over 2 however many times and continue to get answers to this expression. So now I want you to use all of that you just watched to try and solve these 3 equations. I know these can get a bit confusing, but the more you do, the more they'll start to make sense. So do your best to not only list all the answers from 0 to 2 pi, make sure you're getting all of them, also writing a general solution for each of the following equations.